Hello, everyone. Welcome to another webinar from IMESH. I'm Anas, Product Marketing Manager at IMESH. First of all, a warm welcome to you all. So today our focus will be on the topic path to app modernization with API Gateway and Service Mesh. As we all know, today businesses are supported by a fleet of microservices. So as time passes by, it gets a bit difficult to manage all these microservices. So that's the primary reason why we came up with this topic. As for the speaker, we have Ravi Verma, who's the CTO of IMESH, and he has over 13 years of experience in developing large-scale cloud system for big-scale companies such as GE Healthcare, Samsung, Baxter, etc. So first of all, during the webinar, if you have any questions, please don't forget to put them in the chat box. Right before we wrap up this session, we'll be having a discussion on that. And if you haven't yet filled up the form on the website, you can do that by following the link in the chat so that you will get the replay for this webinar on your inbox. Okay. So, yeah, about IMESH. So we launched IMESH in 2023 with a mission to simplify and secure the network of cloud-native applications. And as of now, we offer enterprise support for Istio and Envoy API Gateway. And also we have an AI-based observability layer on top of Istio. So if you are kind of looking to adopt Istio or, need any kind of support for implementing Istio for production, you can feel free to reach out to us and we'll be able to provide you the service. So with that being said, let's hand over the mic to Ravi. Ravi, over to you.
Thank you, Anas. Hello, everyone. Good morning, good afternoon, good evening. So as Anas rightly mentioned, we'll be covering these are the topics. Like today's agenda will be app modernization journey. What are the things we are looking into 2023, how to migrate, like not how to migrate, but what all the key things, key components which will be coming into the app modernization. Then we'll be seeing like what all the components. Once we discuss that, then later we'll see what is the limitation of API gateway and how it cannot solve all the problems and what else we can use to solve our problems. So we'll discuss about something a bit about Istio Service Mesh. Then we'll discuss about various implementation scenarios, not all, but few of them we'll be discussing here. There are a couple of more scenarios, but in the interest of time, we are keeping it not like we'll not be covering all the scenarios, but few major scenarios we'll be covering today. Okay, so without any further delay, let's go to our first thing. So whenever we start or when we talk about app modernization, so the journey basically starts or when we discuss about microservices, cloud, Kubernetes, containers, all those things when we discuss, all those things are kind of components of modern technology stack, where everyone is going to cloud or public cloud or private cloud based on that, so that applications can be extended or scalable. Like we can scale it at any rate and to whatever extent we want. So microservices, like it's a lot of microservices or small workloads will be created, and it solves the problem of faster and frequent deployments. Like even the development can be faster because a specific area is worked by a team, and as it is not dependent on any other features of the complete system, it is very easy to test and deploy it very frequently. Cloud, managing our old data center and all, it is sometimes tricky, difficult, and it's kind of cost impact as well. So that's where cloud helps a lot in handling the infrastructure for the deployments and all. Kubernetes is another, we can say, as a framework which manages microservices very easily and which can be used to scale to any extent. So that's the thing. Now coming to the like why we need this kind of thing. So transactions are like nowadays it's going over and over, and it has increased a lot. Like all the things, almost everything is happening over the network and on the cloud. And with that said, new things coming into picture. So API gateway and load balancers, you'll be hearing always, kind of always, you will be hearing these two terms. So we'll be kind of looking into that today. So whenever we talk about this, our generally our journey starts with API gateway. So let's discuss on that. So this is a typical scenario in which our microservices, how it can be configured and all. So we can assume or in this scenario, what is happening here, it is a EKS cluster here, and it is running 2 microservices. For the simplicity, we have kept it very simple, but in the real scenario, it can grow big a lot, and it can make even a lot more complex scenarios. But to understand these scenarios, we have kept it very small and simple. So here the thing is, we have a author service, another microservice is running, which is eco server service. It is running inside a EKS cluster. These two microservices, as we know, in a private cluster or usually, or for that matter, any cluster, directly we cannot access any of the services from the outside of the cluster. For that, we have multiple ways, mainly like we can expose it using node port, load balancer, or ingress, like different ways are there. So in this scenario, let's assume here these services, and they are exposed using a node port, and node port is connected to network load balancer. So we can see here, each services has exposed their own load balancer to get traffic from the outside of the cluster. As we need an entry point, that's where we need to export our port out to get the traffic. Here API gateway, here we can assume like we have a AWS API gateway. From there, we can configure it to allow internet traffic to enter into our cluster, but directly we cannot go into direct like this AWS API cannot be directly integrated or cannot be brought directly into the cluster. So it has to take some path. So these are the paths where we are seeing. So API gateway will be there. After that, as it is in a private subnet or private VPC, directly it cannot be accessed from the outside network, or it is not exposed to public network. So in that case, we create a VPC link so that this AWS API gateway can enter or interact with the cluster. So VPC link will be there, and these are the internal network load balancers. These are not directly exposed to internet. So in that case, what happens? Any request coming to API gateway, that will go to VPC link. Like routing will happen here, definitely based on the endpoint or whatever request we want. Suppose like if someone is typing abc.com and /xyz, it will take the route. The routing will happen. L7 routing will happen here, and it takes the path because the endpoint is registered for this one here for this endpoint. So it takes this one, and it will forward the request to respective service. If someone is calling any other endpoint, it will go to the first one. So that's the configuration. It is handled here. Okay, so in this case, one problem is there, like the one major problem in this case, if we see, it is having few other problems also, but if we see, we have, as we have seen, for each and every services, we will end up exposing a network load balancer. So assume if we have hundreds of microservices, we'll end up using hundreds of load balancers. So in that case, the cost will go up, and it is not recommended also to have those many load balancers for each and every services. It's not good to expose all those scenarios or all those services directly to one load balancer. It will be kind of mess. Okay, so to simplify that scenario, what we can see, we can have one load balancer in which it can expose all the ports, but still we have some problem here. Still these services need to be exposed via a port here, node port. So that way, if we assume, we can have if there's thousands microservices, so 1,000 ports will be open, and all those things need to be connected even using load balancer. But It means if we are opening more and more ports, it means we are giving more chance or more area of attack for the attackers because it's having a lot of ports open. So this is also not very good thing. We will discuss how to resolve that and where Istio comes into picture and how to resolve that scenario. In the simple scenario, another simple scenario, what we can see, like instead of network load balancer, what we can use application load balancer. In that case, what happens? The responsibility of application API gateway, it shifted. A few of the responsibility will be shifted from here to application load balancer, like routing, circuit breaking, all those things can be handled at this level. This guy can still do advanced things of API gateway. For example, API lifecycle management and protocol conversions, all those things can be handled still here. And we can introduce another application load balancer here, which handles the traffic or L7 routing mainly. So these are two simple setup. We will be discussing now more on what all the things and what all the limitations on API gateway, why it needs more. Okay. Yes, we can do a lot of things with API gateway, but when the services grows big, like we have a lot of services coming into picture again and again, it's growing big and all, it can sometimes be difficult to handle all those things and all the internal requirement of the services using only the API gateway. API gateway is the front door, but it is not, or it is not having all the information about the internal network. So few limitations here we have listed out, like it is handling the traffic at the edge only. But if we have some requirement to talk internally within the services, there's sometimes those becomes tricky. And what if one microservice has to communicate to other microservice, and that goes from all towards the API gateway and come back to the cluster again? It creates unnecessarily extra hop, and this kind of design is kind of, it should be avoided because it unnecessarily creates a hop, and it is called a hairpinning problem usually. So few other things also, like multi-cluster, multi-cloud communications setting with API gateway, that to single API gateway, it is tricky. It cannot be handled at that level. Definitely, we can have a dedicated or dedicated and multiple API gateways. We can add it, federated API gateways. We can introduce based on our need. So coming to the third point, like it is having visibility only whatever it is entering into the edge, like at the front door, but whatever happening behind the scene inside the cluster, that kind of information it is not having. So we cannot detect, for example, if a service is failing at a very end point. Suppose we have 5 services and internally 2 of the services are talking to each other, and one of the services delaying or failing, and because of that all cascading effect is happening. But where it is exactly failing, that cannot be pointed out at that, or that may be difficult to identify with the only help of API gateway. It is having few information which is entering, but what is happening inside the cluster, no idea. Plus, if we want to restrict something within the microservices itself, like if one microservice wants to talk to another one, if I want to allow, whether it is really allowed or not, that cannot be controlled, because if we are directly talking to each other, they like all microservices, and those do not go via, which is via API gateway, so they'll API gateway will not be knowing that what is happening inside that, and definitely it is not recommended to reroute internal traffic to API gateway and then enter again to the cluster. Okay. One more thing is that traffic after the S is usually not secured, like we think, okay, TLS termination is that done at API gateway level, and after that it enters into the travel, like internal either EC2 or any VM or cluster, all those things. So usually those kind of things are not secured, but yes, definitely we can make it secure by implementing certificates and or TLS, we can bring it. But yeah, it needs a extra configuration, definitely. Okay. So that's where Istio Service Mesh help. where all those internal traffics can be controlled, and that too at very granular level. We can control each and every traffic, whatever we want, to whom a particular service wants to talk. All those things can be controlled. So what happens, what Istio does, it injects a sidecar to each and every microservice. So in that case, what happens, we need not to change any code, any logical code inside our deployment, whatever we have, like our workload application, nothing to be changed. Only we need to enable the service mesh, Istio service mesh, and it starts working from there. It takes all the responsibility of configuring, rerouting, MTLS, all security things handled at this level. Okay. So a few of the scenarios we'll be discussing today, what all those. Okay, so let me start with the pointer so that I can explain. Okay. So here we can see, here we are introducing a ingress. So in this case, what happens, our external traffic enters here from API gateway, and definitely, as we discussed earlier, cluster does not allow direct entry of any external traffic. Definitely we need to open certain port to listen. So I was discussing, we had two things we had discussed, node port and load balancer. But in those cases, both those cases, we were having problem, like multiple ports need to be opened to get the traffic inside. So that's where ingress helps. Ingress exposes only certain ports, whichever we want to open, say 80.443, that we can enable, and all the traffics can enter only through those two ports. And all the traffics can be routed to all the microservices easily from there. Even if you see this one, this is outside of cluster, but it's still like on the VM, it can be managed from the same Istio control plane. So this is one of the scenario in which API gateway, like we receive the traffic at API gateway, that is forwarded to Istio ingress, and all the routing happens. So here also what happens, L7 related, like service related routing usually happens at this level, and all advanced API gateway related thing can be handled. So it means they can do a distributed job of doing advanced API management here, and all those writing API routing at this level, so that the load is balanced and the traffic can be handled very easily. It is having few cons in this scenario. Like one is from here, what we can see, from this to this communication, it is not secure. But yes, we can secure it by enabling TLS here, so that this communication again becomes secure. Okay. Another thing is, we are seeing here, like one entry already in the network traffic is entering here, and we are doing some processing. Here also we are doing some processing again. So it's kind of, we can say it is adding one more hop to the all traffic, like one processing done here, another processing is happening here. But we will discuss about that like more. How do I add all of those kind of things? Okay, coming to the second scenario, as we were discussing in that the first scenario, hop. So it was getting added to in between microservices. So to avoid that, what we can do, we can bring API gateway all together to our cluster boundary. So in that case, what happens? Any external traffic enters to API gateway, processing happens here, and from there directly all the traffic can be routed to required destination without any hop. Okay, but in this case, what happens? In this scenario, this cannot be done with the cloud provider's API gateway usually. What? Because that is not an application or running in a pod or something like that, that is provided by a cloud provider. So that bringing it here directly into the cluster, it is difficult in that case. But yes, other API gateways, if we are using, that can be brought into the cluster directly to solve that problem, extra hop. So again, we see it is having one cons, like again, these traffics, whatever I highlighted here, these are not secured. So what we can do, That's another scenario we have. In this scenario, what we can do, we can enable Istio enabled API gateway. In that case, we get the traffic from outside, and all those traffics from leaving from API gateway to the internal services, those can be secured via MTLS security. So in this case, what we can see, all the communications are secured even after API gateway is done, and we are not seeing any hops here. But yes, in this scenario, what can happen? The communication or the configuration can be tricky, because here we need to configure one is entry point is this, which is from the outside, and this is exit point out. And we need to configure Envoy in such a way that it is not disturbing our external traffic, because that is coming from the outside. It's not within, like usually what happens in these scenarios, in and out, all those communications goes through API, this one, Envoy proxy. But in this case, we need to configure in such a way that we are getting direct traffic directly into this one, and the out traffic from this one goes through Envoy to achieve our TLS. Okay. Yes, so we were discussing about where and all it is helping. So we can see all those internal communications we can, or let me go back to this diagram. Istio is handling all those microservices, and all the microservices we can enable sidecar injection, so that each and every microservices are secured. They talk to each other over a secure channel. Okay, so that we can see very easily. And it is, and one advantage of Istio is that it can manage at one single control plane. We can manage all microservices, even multi-cluster visibility also we can get it here. We can know what these microservices are like, what's the rate at network it is like entering the traffic and coming out, and what is the latency each and every microservices are taking time. All those things can be visualized with the Istio. So it's such a very powerful tool. So that's where we can see where Istio and API gateway comes together to manage a distributed system very efficiently and easily. Okay, so that's all for today's session. If you have any question, you can drop a message. We can have a look. And one more thing to add, we will be covering more advanced topics related to the same API gateway, and do we need really API gateway or not, and what are the scenarios in which we need API gateway, what are the scenarios we don't need API gateway. Those we'll be covering in our future sessions. So stay tuned.
Thank you. Thank you very much, Ravi. I hope it was very valuable for all the attendees. Okay, so if you have any questions, I think you can drop it in the chat or unmute yourself and ask here.
Yes, okay.
Yeah, now you can, if any one of you have any questions, you can unmute and ask here. We'll wait for a few seconds, or you can post in the chat box. Also, one more thing to note, that if you need a reply of this session, you can fill up the form in the chat, and the reply will be delivered in your inbox. We don't see any questions there, so let's wrap this up. So before you go, if you have any requirements regarding consultation on your Istio journey, or need Istio support to deploy it in your production setup, feel free to reach us at contact@imesh.ai. With that being said, thank you everyone for joining the session. Thank you, Ravi, for your wonderful presentation. Have a wonderful day. Bye-bye.
Thank you.